All right, now things have gotten a little bit more interesting or otherwise complicated. Now we need to work with AC. Now AC current is is a wave. You are switching the polarity of your source. And so resistance becomes a little bit complicated in capacitors and inductors. So we are going to calculate the total impedance of this circuit. We have two capacitors, initially in series, and then the other capacitor is in parallel with a resistor of 47 ohms. First step is we need to calculate the total impedance of the circuit. Let's just treat the capacitors as resistors. They're a bit weird, but they're resistors. Resistor 1 in series, and then two resistors in parallel, the classical parallel equation. Let's sub in the values. Because we have a sum of these capacitors, we have to put them in rectangular form. That gets complicated because everything else is in angular form, and because we want to do multiplication and division, everything needs to be changed to angular form. As always, I do everything using trigonometry. Classical Pythagoras' theorem is 110.5 ohms. And the angle, we get 64.8 degrees. We can now put this into our equation. We can multiply and divide the magnitudes like normal, but angles do not get multiplied or divided. In this case, they're added and subtracted respectively. So 0 and minus 90 degrees get added. We get 42.5 with an angle of 25.2 degrees. Now we can't add these, we need to change everything into rectangular form. Add them all up together and we can leave the total like this if we wish.